Good afternoon, everybody. Welcome to day 9. We're on our last day of Intro to Coding Live. We're going to pick up where we left off with the Powerball logic and kind of see if we could bring this across the finish line, and then we'll assess what we're going to go over for the next project. So I believe we were just finishing up talking about the getting the user input for the white ball, correct? So
Correct.
when we move, so we know that the difference between the two um, sets of logic is we're getting 5 white balls with no duplicates in there. So that actually pulls in a little bit more. That was a little more difficult than what we've got here. So I know for generating our ticket, if you remember, we just used a single random
Yeah.
in 1 through 26. So effectively, we're just going to duplicate that kind of logic, but we're not picking a random number, we're prompting for it. So as we head into this while loop, the reason why we're using a while loop is we know we need one entry here, but we don't know how many times the user is going to enter in information before we get a valid entry. So that's why we use a while loop here. Um, so the first part of this is we do our input function. This gives them a nice, pretty prompt to be able to give them an idea of what we're looking for, and we just assign that to just a regular variable. So we know that this is going to be a string. Then we run through our logic check. We run an is numeric check to see if the number they entered was an actual number, and we typecast we typecast that num into an integer and check if it's a range between the range of 1 and 26. Remember, range is exclusive, so the last number is our limit, but the numbers we're looking at do not include the last number here. Now the reason why we can do it, the order of how we do this is important. We want to check the is numeric first because we need to make sure it's a number before we try to typecast it. Now, I'm going to reverse the logic so you can see what happens. Now, when we run it, everything's functioning fine now. Okay. 1, 2, 3, 4, 5, and now we're going to put Apple. Because we didn't do the is numeric check first, we instantly try to typecast the num variable into an integer, and that's why we're running into this issue here. But if I reset this logic and try it again, it actually captures it. Do you guys see that?
It captures.
It checks the is numeric first, so it waits to make
Okay.
sure that it's got to check to make sure it evaluates the left side before it touches anything on the right side.
Yeah, so it's making sure that whatever they number they choose is within range.
Well, that's what the second part does. The first part makes we're ensuring that it is a number.
Oh.
Yeah, because what caused the other error is because we tried to take the word apple or the string apple and turn it into a number, which we know that that just doesn't work.
Okay.
But by having this is numeric check before we try to typecast, we capture it there. So when it hit apple, it didn't bother looking at the rest. Because with an and, both sides have to be true, right?
Yeah.
So as soon as that hit false, it jumps to sorry, that's not a valid number, and shoots you back through the while loop. Sorry.
Okay, that makes sense.
The while loop is right here.
Yeah, that makes sense.
And then we just typecast it and we move on.
Quick
Is your lo
question.
Go
When you
ahead.
put ticket red, is that a dictionary? What is that?
Yes, that's a dictionary. So your reference, okay, so you have that's the random generated, but right at the beginning of this function, we create our dictionary stub. So
Oh,
what
so
I
you're
mean
just
by that,
filling the empty dictionary with
well, it's we're not actually we're not actually starting with an empty dictionary when we hit these pieces here. We jumped into the function, and this is like you remember when we used the result variable in a different function that we declared, and we set it up right at the top. Do you remember that?
I remember.
So that's we're using the same concept that in here that we know that we're going to need our variable. And why this is even more important doing it this way, because when we get into our white balls, we're going to append into a list. So we want to kind of be explicit and make sure that list exists before we go into there. Do you see something wrong with the logic, Dominic? Go ahead and elaborate.
uh clear yours real quick
Okay,
and then run it?
go
Would you
yes,
like a randomly generated ticket? Yes.
yes. We won't see the results of that. What I have to do is I have to print the player ticket. Oh, it's there. I just commented it out. So run it again. We want yes. So we got a ticket.
Why is mine different? I copied yours.
Okay. Did you copy it from the Slack message?
Yeah, did you fix it since then?
Yes, I noticed when I was looking over it, look at the question and then look at how the logic is.
Okay, hold
So
on.
that looks all right, but what was transposed are these two variables in here, the Boolean variables.
So if user response lower y response yes.
So you're the first part, yours probably says generate user ticket with true in the
Yeah,
parentheses, right?
it's
Flip them.
true and then false. It
Yeah.
needs to be false and then true. Okay.
Yes, because I mean, that was a quick fix. What I could have done was I could have gone in here and changed the logic here instead.
That seems like it would take more time though.
It basically all you have to do is if I go not user select,
Oh, I guess it wouldn't take more time because I'm overcomplicating it again.
no worries. That's that's the nice thing about Boolean logic is it's really easy to flip the switch. But I was looking at this part when I was looking at it and I was like, wait, that doesn't make any sense. So then all I did was I just flipped the variables to get it to follow the flow that I had in mind. Outside of it, it looks right. It's inside that this could start getting confusing and whatnot. In this particular case, maybe it's time to revise the actual name of the function. You know what I mean?
Yeah.
So
Okay, I got
that's
my
all
book.
that's all that was. It was something that I literally noticed about 5 minutes before everybody was jumping into the Zoom call.
Yeah, because if I said yes on mine before I switched it, it was asking me for numbers instead of
Yes.
generating the
Yeah.
ticket.
And I didn't even think about that while we were running through and testing it and that sort of thing. So, but yeah, it is a pretty quick, easy fix. But that's also, you stop and read the message that you put in there. So you could easily have changed. You could have also have changed the actual text here to "Would you like to create your own ticket?" or something like that. There's multiple ways that you could go through and solve that one. That's the beauty of dealing with Boolean logic is you have choices here. So this just becomes a design decision. And honestly, what I did was just the fastest way I could hurry up, fix it, and move on. All right. So we want to start heading into the compare results. Now we have our two tickets. As we see right here, I'm going to put an F string in here. So we've got some debug logic. We've got our winning ticket. And our player ticket. As you can see, when you start doing a lot of print debugging, things can start getting a little messy. So sometimes it's best to just use those F strings and track your input a little bit better. But this is another reason why we're outputting the ticket. It's so that we can check this way we can manually test our logic when we put the compare results in there to make sure that we're hitting all of our win cases. And that's what we'll start working through now. All right. So as we covered yesterday, these are all of the prizes and criteria to qualify for those prizes from the actual Powerball. We're not going to jump into any of the extended stuff. We're going to try to move through this as quick as we can. Given this, you guys can let me copy this and I'm going to paste it into that spot that we had. So it's got the updated thing for you guys. There, that way you don't have to manually change it. You could just go in and copy it out. What I can do is we could take about, you think 10, 15, 20 minutes to take a shot at this, or do we want to talk through our logic, or what sounds good to you guys?
Give it the good old college try. I'm just trying to track along the best I can here.
Yep, no worries. One big thing that we did discuss when we were mapping out, when we were kind of writing our notes, is we're definitely going to be using combinations of if statements and the or keyword. And what you've got with this is you've got the example of the and keyword. So if just as a quick refresher, with or and, we have complete Boolean expressions on both sides. Okay. Does that make sense?
It's numeric and range.
So this is a full Boolean expression. See how I'm highlighting over this?
Yeah,
And if you look at the pop-up, it says it returns true if the string is numeric, false otherwise. So just this method, this string with a string method gives us the ability to have a Boolean response here. And then this is a Boolean as well when we're taking whatever number we have, converting it to an int, and then checking if it's within inside the range. That is also, this whole thing is also a true or false statement. So that's just the key to keep in mind. I'm going to put in the other way to write this. The second part of this would be int num is greater than 0 and int num is less than 27. Okay. These two do the same thing, but notice how I'm repeating the int num. It has to be on both sides. Okay. That's a key spot that even sometimes I forget about, where you might be inclined to write it like is greater than 0 and less than 27. When we speak that out in English, that makes sense. But in code, it doesn't, because that's an incomplete statement. Okay? That's the part that I wanted to kind of go over a little bit, because I recently made that mistake with a different example. Okay? So let me open up breakout rooms, or set up our breakout rooms. I'm going to set up the breakout rooms, and I'll auto assign you guys. I'm going to pause the recording. Okay, so I didn't realize I wasn't recording, so I'm going to just quickly cover this. We went through to flesh out the compare results function here. We feed in the two dictionaries, the winning ticket and the player ticket. That's always a good habit to map out your logic, especially with this being our table that references what our criteria is and what the prize is. So we went through, we made a couple variables to track our matches. We checked our red ball, which that's an integer, so that's an easy comparison. And then we went in to check our white balls, which, if I remember right, that's a list. So we enumerate that to be able to get the index of our where we're at in our list and the value that we have. We use the same index to reference our player ticket, and we compare both values to see if they're identical. We made that possible by sorting both of the lists before we got here. So now we can just check position for position. And as we know, you can't have any duplicate balls, so then we can just roll through with that. Then we store our white matches and red matches into a matches tuple, and then we can iterate through that to compare against our prize payouts. So in a nutshell, that's pretty much what we've got. We use a result variable to be able to return our result of our ticket, and it should work. I'm going to just hit the play button. We'll do a random generated ticket, and we have these in here for our debug, and we can see they don't match, so we lose. And there's something else there. We'll check that later. But any questions? Okay, so I know we don't have a lot of time, so we're not going to be able to complete the entire next project. The next project is a poker deck. the poker game, if you're familiar with it, you have again a set of criteria for winning. This is our weighting of the different types of hands we can get. We know that our card deck is made up of 52 cards, 4 suits, and the numbers 2 through 10, Jack, Queen, King, and Ace. So I know we won't be able to get through building a full poker game, but what we can do is we can start by working on trying to build out the deck itself. So I'm going to create another Python file here. And we can start mapping out our ideas. So our task is create a deck. And if we have time, we can actually go through and try to draw cards from that deck. Anybody got any ideas on where we will? Well, we could create a deck. What are the other parts we need? Yep, 52 cards in a deck. No jokers. If you add jokers, that's 54 cards. So we have our criteria. So we have 52 cards. We have 4 suits, right? Hearts, spades, diamonds, clubs, right? And then our values, I believe it's 13 values. Well, we start with 0. There is no 1 card. We have 2, 3, 4, 5. Well, we'll just do 2 through 10. Jack, Queen, King, and Ace. And that's pretty much our deck, right? So anybody have any ideas on how you'd turn this? Now, I'm going to back up a little bit. Python doesn't inherently know what a card deck is, so we have to build this. So do we have any ideas how the different approaches we could use to build a card deck? Okay, so we're going to record these options here. Option 1, a list. Okay. Anything else? We're just tossing ideas out here for right now. A dictionary?
Yeah, I would say dictionary to at least get the deck of cards in there and then list the cards after.
My
Well,
only
right
thing
now,
with a list is it couldn't really be a list because you have to assign everything a value, right? So you would almost need like
well, what can you put inside a list?
uh
Do you remember?
another list, a 2D list.
You
Well,
can
no,
put
because
it.
what you're putting in the list is like when we were doing the licensing, like for that chick's license or whatever, is like, right?
The key
You're
and the
talking about the
information.
dictionary. That's the dictionary there.
Oh, okay.
Remember, dictionary's key value, and a list is indexed.
I
So
see.
it looks like. So the list looks like 1, 2, 3, dot, dot, dot. And then our dictionary looks like.
I would say dictionary is probably best because then you could list the cards and numbers to those. And then I
What do
think
you mean? What do you mean? I'm trying to wrap my brain around.
So
so I
like
can try
for
to.
example, like there's different types of aces, right? So like you would have aces be the variable and then I guess go with like well no, you would name it, I guess, deck of cards for the variable for the dictionary and then like name aces and then add what kind of aces are in there, right?
I'm have. Well, um, one thing to keep in mind about dictionaries, the key has to be unique, right?
Yeah.
Um, sorry, I'm adding these as I see them in chat, and we'll catch them. Okay. Um, you can do it with a dictionary. You are not wrong, but maybe it's the way I'm visualizing how you're explaining it. That might be my issue in trying to understand what's going on.
I guess what I'm trying to get after is like the key would be like the deck of cards and then the name following, I guess it would be like where so in line 8 where you have name, that would be deck of cards.
Okay, so what's my variable name?
Um let's do deck of cards.
Like this?
Yeah.
I'm typing this out so I can help
No,
visualize.
yeah, this
Yeah,
is helping
okay.
me too, so. And then I would go with because now we're at the value, right?
Well, now we're at the key values. This is the variable name, and inside it we have keys and values.
So for the keys and the values, for example, could the keys be like each type of card and then like their corresponding value?
You could do that. So what you're
That's
talking
where I was
about
like getting
is
after.
like
My terminology.
two
Uh,
spade
yeah, correct.
or something of that line. And
Correct.
then you give it a value of, I don't know, two. This is just hypothetical here. And then your three of diamonds, give it a value with three. That's what you're talking about right there, right?
Yeah, like putting
Okay.
in like not coding terms, but like just kind of putting them into
You're
like
mapping it out. Okay.
yeah,
Yeah. Okay, I see what you
that's where
mean
my
now.
head goes.
Okay. Now, Takesha mentioned sets. Um, we could use sets. It might make it a little bit more difficult, but we very well could do that as long as we use a similar naming strategy like what Derek was adding here. As long as we make sure that there are no duplicates. We know that part. Um, for tuples, I see Marcellus mentioned tuples. I can envision using tuples, but maybe not as the base data structure. Or what are you thinking, Marcellus? You want to try to elaborating?
No, I'm just throwing out random
Okay,
things.
I
I'm just
gotcha.
thinking like a tuple, like in a set. I'm thinking like the same thing as a dictionary, a key and a value, just in like a tuple form. I don't know.
Well, one way, remember you could use combinations. So one way you can look at might be a list of tuples. So um, inside we've got a tuple, and we'll say we're going to use Derek's naming strategy right here. You could do that with a value, or you could, if you wanted to, you could break it out So, um, when we're building the deck, what are the different ways we need to be able to use to compare it? And this might start modifying how we're looking at how to do this. We can compare by overall value, right? So in this case, we're talking about our 2 or 3, right? What's another way we can compare cards when we're thinking in
By
like poker
suit.
terms? Yes, by suit.
Couldn't
And
you do
this,
like the suits along in the dictionary as like values?
well, it it depends on your implementation, okay? So regardless, so the the trick, the thing that you have to majorly keep in mind when dealing with dictionaries is that key has to be unique. Okay. So if we move the suit to a value, right? I'm just going to type it out right here. What does this do? What does that do?
Is that like reassigning the variable almost?
Yeah, because it's basically I in a declaration this won't work. You'll get a syntax error.
Yeah.
But
All right.
if we access the 2 and we set that's where it starts getting a little bit a little tricky. So um you can take the key and convert it to, well, these are strings, so you could do string operations to be able to mitigate figuring out your diamonds and stuff like that. That's one way that would work if you feel comfortable doing that.
I'm just throwing stuff out there like
No
myself.
worries, no worries. Um, but what's one action that we have to do to the deck once we've got it built? What's a deck? What? No matter what card game do you?
Shuffle.
Yeah. So that's something that as we're going through this, so
Can't we just
we started with identifying the different things that we can do. Um, tuples are immutable, so we can't shuffle those, right?
gotcha.
So now we can't use that. But go ahead. Sorry for interrupting you there.
No,
What was
I was just wondering if you could just, for example, give everything a key or I don't know, like I was saying, 2A, 2B, 2C, 2D,
Mhm.
and then when you go into like present that information, it checks it into a dictionary, and then it's like, oh, 2A represents a club or something like that.
Well, you could still, so the cool thing about the suits is their first letters are all unique. So you can actually use the 2C for 2 of clubs, a 2D for a 2 of diamonds, a 2S for a 2 of spades, or a 2H for 2 of hearts. So that thinking does work. I would highly suggest not trying to encode them into like A, B, C, D, meaning this and that. That just makes it so that you have to start referencing. You see what I mean there?
Wouldn't you still have to reference it? Because if I present,
At this point, yes, you still do.
hmm, okay.
So if you go, what does that start looking like? And then remember, we can embed and we can combine data types. I have a completely different mapped out value system. So but as long as your values match up to your mapping, it kind of makes sense, right? But it does start getting complicated. This is just one way to do it too. Another way, you could use tuples in a different manner where you could go like this. You could actually index with a 0. This makes it a little bit tricky because there is no 0 card. And spades, and that could represent your 2 of spades. Or you could take the literal value. The tricky part would be remembering that your ace is a 14 of diamonds. And the tricky parts there is remembering that there's only 13 of each card in a suit. So it still requires that you kind of make some kind of notes. But that's 2 different ways that you could probably approach that. Is that helpful? Or are you guys seeing it, or do you need me to simplify it, or what works best for you guys?
What do you think the best way to do it is?
Well, I have a way that I did it, and I may have over-engineered it. Okay. But it's similar to some of the stuff that we've already covered in here. If you'd like to, you could try to take a shot. Now, one thing that we can keep in mind is that gets tedious to type 52 times, right? Same thing here. All of it gets tedious to type if we want to hard code it 52 times, right? So there's ways that we can populate it without having to hand code it. Do you guys want, I can use the breakout rooms. There's 3 of us in here. We can use the breakout rooms, or we can just kind of pause for a little bit, let you guys work through things, and then have a look. What works best for you guys?
I'm just following along. I'm not gonna lie, like I'm getting my packing list together and listening since I'm not very much of like help to anything right now.
Well, no, you are of help. You are okay. I'm going to, well, this right here is not a bad idea. Not at all. And we just have to think of the ways we're going to process it. That's all. Because I'm the dictionary is not an ordered it's not an ordered data structure, so you can work on getting your shuffling going on there. I have to look at how to do it, but right now we're just looking at creating the deck. So if you want to take a shot with that, you're completely fine, or whatever works for you best. All right. I'm going to pause really quick here. All right. So I know we discussed a couple different methods. Some of them were fully string based. Does anybody have any other methods that they think might work for them? I know I've got an example sitting up here. Okay. So what I ended up doing, I know just like yesterday, just like with the lotto, we're importing random, but we're not using it when we build the deck here. So I ended up throwing this all this logic inside this generate deck. And what I'm going to do, I'm going to copy this logic. Paste it over here. And get rid of, I'm going to get rid of this for simplicity for right now. And what this is doing, I think the majority of us were talking about using a list for some combination, right? Was anybody else looking at trying to use a different base structure?
I was on board with Marcel with tuples.
Okay. Well, this particular example does use tuples, but the tuples are inside the list. It's harder to see though. And I know we've seen tuples with two values. I don't know if we've seen if you guys are used to seeing tuples with more than two values, but it's definitely possible. What this is doing is this is going through, we start our loop with our suits here. So our first loop through, our suit is hearts. We start this rank variable at 0, and then we jump into a sub loop. And this loop is counting from 2 to 11, which we know that the 11 is not included. So we're going to get the numbers 2 through 10. And that's going to be applied to the variable value. So the first piece of our tuple, we typecast the value into a string. We add the suit, and then we add this rank. Now, the reasoning why I decided the rank piece I added later when I was thinking about this to try to work on calculations for comparisons further into building out the game. And then for each iteration of this loop, we add 1 to rank. So our rank runs through the values 0 through 8. That's what this is. That's why I made this explanation. And this kind of already tells you that there's a little bit of complicated logic that deals with other stuff here, because I have the card value, and then I have a numeric rank that I make that equivalent to. The reason why this starts at 0 is, well, because we usually count from 0. I could have easily adjusted that to do 2 through 10 and then 11, 12, 13, 14, or whatever made sense. This is just the approach that I chose. And as long as I aware of that, I make sure that the rest of my logic throughout the rest of the program is dependent upon that. For the face cards, I went ahead and ran through another loop that just effectively does the same thing as the hearts, spades, diamonds, clubs. The first value is Jack, so this is Jack. The suit comes from up top here, and then the rank just continues on with this numeric order here. And then once it gets through all of the cards of the one suit, it jumps up, gets spades, resets rank to 0, and does it again. So what we end up with is deck equals generate deck. And then if I go for card in deck, print card. Now, when I run this, let me clear this out. When I run this one, you can see how all the cards break out. Does that make sense for everybody? Any questions there? This is using a different logic base, and you can see that I'm adding 2 strings and an integer because of how I was trying to map through the comparisons later. Does that make sense to everybody?
So what outputted was def generate deck, this deck with an open list, well, empty list.
Mm-hmm. Yes.
And for suits, hard spades.
So I know when you were talking about
Okay, I see what you're doing.
you assigned this to a variable, I just short circuited it and put it right inside here.
Yeah.
Okay, because it's only 4 words, so it's
I was
easy.
gonna say what you did look similar to kind of what I pulled up.
Yeah, it is very similar. I didn't use I didn't use any additional variables inside here other than this rank variable.
Yeah.
That's just a design choice that I went with. So both of them will do the same thing.
And then
Um,
basically when you get to for value in range 2 through 11, you're only working with like the face cards. Well, not the
th
face cards.
this is
The
the numeric cards.
yeah, the
Yep,
numeric cards, and then
and then the face cards.
yeah, and then you're putting those into strings
Yes.
and indexing those with the name and the rank.
Yeah. So right here's your result right there for each
Yeah, okay.
element. Yeah.
This makes sense to me.
Okay. And then um our next step, well, just to make sure that we're on track, I'm going to comment these out, is this is always a good habit. We're going to print, we're going to print the length of the deck because obviously we want to make sure there's 52 cards in the deck. Okay. So that's how we make sure that our loop did what we expected it to do. Just a quick, simple check, and then you can comment it out and then move forward. Now, I did add the random. I know we discussed it a bit. We discussed it briefly before I started the recording back on. We're going to look at using the shuffle method here because to shuffle the deck, we don't want,
Ran.
yeah. So we shuffle modifies the deck in place. So we can actually go random dot shuffle deck. And what we can do is we will uncomment that, and I'm going to copy this, paste this below, and I'm going to put a separator in here.
It's just the 4 things, yeah.
Okay. And then when we run it, this is our deck in order. We can see clubs are all lined up, all the cards are in line. And from one shuffle, we now have a shuffled deck.
Then we would have to, wouldn't we have to strip at this point?
No, we don't really need to strip because right now, this is just data, okay? We could, now I do have, now what we can do, I do have a little bit of logic in here to where we can draw cards from the deck. And this is going to look really, really familiar. So if we go hand 1 equals the deck, because we shuffled it, this works out really well. And I'm going to explain this here in a minute. We're just going to grab those like that. 2 equals deck. 1, 10, 2. Now, do you guys remember what this is right here? What we're doing right here? Okay, what we're doing right here is we're slicing from the deck. So if we look at this, if we remember our slicing, inside the slice we had start, stop, and step, right? Strap. So what this one is doing is it's starting from index 0. It is stopping at card number 9, and it's grabbing every second card. What is that simulating? Anybody? Well, the shuffle's already been done.
Start, stop.
So we're assigning the cards to a hand, but by doing every dealing, yes.
Then hand 2 would have, so hand 1, correct me if I'm wrong, because if we're going by the index, it's only number cards in hand 1. Hand 2 adds face cards in there.
No, this is the whole 52 card deck.
Okay.
So Marcellus had it. We've already shuffled the deck, right? This is dealing. Now, have you ever been in a card game?
To tell you the truth, I don't play much cards, so I'm not really like familiar.
Okay, so what happens when people are dealing in a card game is you deal one card to one person, one card to the second person, one card to that. You see how now do you see what this is doing? If I print this list, so if I
1 to 10, step 2.
if I print this and then I'm going to do another,
Would it be giving each person 10 cards and then
no. But so we can check. Let's print the length of hand 1. Print the length of hand 2. I'm going to, okay, let's not print these out yet. And then we'll run it. And you see each hand has 5 cards, right? This took working through it to get this down. This is a little bit of math, okay? But we're going to deal a total of 10 cards to 2 people, right?
yeah.
And if we want to deal off, you generally deal off the top of the deck when you shuffle the deck, right? And every other card goes to the first hand and vice versa to the second hand. So if I go through and I uncomment this to print it out, and then I'm going to, for card in hand 1, print card. And then we're going to print this again, and for card in hand 2, print card. When I run this, okay, so this should be the first card, right? The 2 of diamonds. So if we go up at the top of this deck, right there it is. The 8 of diamonds is the second card. We have dealt the second card as the first card to the second player. You see that?
Yeah.
And that's what the step by 2 is doing.
I get it, because it's basically 10 divided by 2
Mm-hmm.
between. So the one, because if you start at 0,
Because 0 is the first index, right?
yeah, and then 1 would mean there's 2 people playing, and then 10 divided by 2, 5 cards per person.
Yeah.
Okay.
Is that making sense then?
Yeah, for sure.
And then we can use that logic to just continuously, you can add another player and you start increasing your step, you increase your,
How
and
would you
you can,
like automate that though? Like if we're playing an online poker game and somebody else jumps in, how
okay, so that right there, you would probably move from hard-coded variables. These are hard-coded variables we'd want to probably move that into a list, right? And maybe call that a players list.
Sure.
And then we do have to start using variables here. You can use variables inside your slicing.
So you would have to have probably,
You'd basically build an algorithm that says, what's my max players? That's going to be my stop for my last player.
yeah.
And then you basically, um, your amount of players is your step, and you would move forward that way.
Gotcha.
If you went with this way, the nice thing about this is you won't run out of index errors as long as you cap your amount of players to the maximum allowed in a poker game or something like that. And I believe, what is it, 10 people or something like that? I don't know. I don't play poker that much either. But you can actually go through the full simulation that way. Does that make sense?
Yeah, for sure.
So there was a different little thing that I did right here. If we copy this and replace the shuffle, can anybody take a shot at what this does?
For index and range, random int. Yeah, it's randomizing the 5 cards that each player gets.
Oh, no, no.
For index and range, 0 through random int, 1 through 5,
I
randomizes
gotta.
deck order in place, changes the list order. This is just another shuffle.
But it's a little bit expanded. It's expanding on just a single shuffle. Okay, do you remember what the random method does? That's another random method.
Is that how many times you're gonna shuffle the deck?
Yes. This is turning that into a random number between a random amount of times between 1 and 5.
For
So you
what
could
well, for what purpose?
sometimes when you're playing with people, they just continue shuffling and shuffling and shuffling, right?
Yeah.
But at least you don't have to watch it here.
I'm not like trying to be smart, but isn't that like kind of irrelevant here? Because like if we're just playing like an online poker game, wouldn't you just shuffle the cards once,
So
like as opposed to this being like a human interaction where you're shuffling it multiple times? I'm just trying to find like a purpose behind like what that's.
this right here, this was a concept to see if I could do it, basically. That's all
Okay.
that really
Okay.
was. And we do have to, but it does bring up a point about the random system and using the random module. These are not truly random numbers. They are a pseudo random. They call them pseudo random numbers. And if you've ever played some various video games, like I can think of Minecraft because it's got the randomly generated map, and that has a spot where it has a seed. If you put the same seed in on several brand new games, you get the same quote unquote randomly generated map. That is how this random works. So you can actually get the same, or technically stacking the deck if you supply it a seed. Okay.
I mean,
This is a
essentially, it's almost counting cards because you know after a certain amount of shuffles that you're probably going to get the same hand again.
Could be, yeah, yeah. Usually on that, and I think I know there's a little bit more complicated stuff behind like card counting and stuff like that. But yeah, this was just it was 2 lines, and it was just an interesting thing that I just tossed in there. But
Okay,
yes,
I was just trying to find a purpose, like as to like where it would fit into this.
yeah. Being that we're not shuffling, being that we don't have any impact over the seed itself,
Yeah,
it just adds another little. That's kind of just I don't know, you call it a trinket or something. That is over engineering.
yeah.
But Yeah, it was I was kind of looking at being able to supply the random int into the for loop. You see what I mean?
Yeah.
And then um my debugging stuff that I had earlier, it printed out, hey, I shuffled it this many times. Hey, I shuffled it this many times, just for a little thing here and there. More of a So there's a lot of comparison logic in here, and I know we're over time. I can send you guys the code, and there are a lot of comments and there's a lot of debugging that you can actually uncomment and see what it does. But it is also a lot of lines. This is the reason why we weren't able to get through all of the comparisons. These comparisons are a lot more complicated than what we were dealing with the lottery game. And one key note, you see how I've added in this get card sum that references another function where I was trying to break that logic apart to the smaller pieces and then kind of compartmentalize the little pieces. This, as I was building through this, it was one piece at a time. So the first thing that I was aiming for was let's knock through the royal flush. And that's when I figured out that if I give the cards a value, given the values that I have, the value 50 is a royal flush. And it made it easy. Value 50 and having the same suit. Same suit, yeah, same suit, straight, and the overall value 50 based on the values I assigned to the cards. Up here. That did take mapping out on paper, and some in a project like this, you'll definitely map out on paper to try to get your ideas kind of straight. But yeah, I can paste these in here. I could paste this into the Slack, and you guys can reference that. And I apologize that we weren't able to make it through the entire thing, but we can run this and see it go. This is still a debug message. It gives you the both decks, but we actually have that's incorrect logic. So there are still a few bugs with it. Any questions? Okay. I hope that throughout the course you guys were able to garner some kind of knowledge and help expand your knowledge on Python if you started from zero or if you started with some familiarity. I hope this was of some use for you. I encourage you to go digging through the projects and maybe tear them off piece by piece and see about solving things. And yeah, it was great having you guys in class, and I hope to see you guys on the alumni side of the house. All right, I'm going to end the recording.